Hi, my name is Raquel Reyes, and I am going to present our final project for the class of Mechanism Analysis and Simulation with Dr. Enrique Juan Urquizo, and we are presenting the flying fish. In the first instance, we were attracted to this animal because it is the perfect example of an animal adapting to its surroundings. As you can see here, the fish leaps from the surface of the water, and with what appears to be an oscillating motion, it delivers a small fly, which they use as a defense mechanism when they are being chased by other predators. Having in mind the motion we wanted to replicate, we needed a graphical representation of the same motion, and we used this program tracker to trace the path of the fishtail, and we achieved this kind of oscillating motion that we needed to apply into the mechanism for the output be in this particular way. It all started with the wings, really. We wanted to develop a mechanism that deliver an upward-downward motion, and we delivered this with a slider crank put in a vertical way. But then we realized that we also could use this mechanism to move both the head and the fishtail. So we used this by mirroring the slider crank in both ends of the linkages, as you can see here. And then we wanted to develop an upper body motion that resembles the oscillation of the other mechanism, but in an opposite way. This because we wanted to achieve a wave type motion where you can see the fish kind of swimming and replicating the motion when they leap from the surface of the water. So here we use a crank rocker mechanism to deliver that. You can see here the complete motion of the mechanism. At first you see the whole mechanism, and then this disappears, so you can see the whole movement of the fish. And in the next slide, you can see the top view of this mechanism, and here it is easier to appreciate the wave-like motion I was talking to you about earlier. Then we knew that these mechanisms are in a virtual way easier, but if we wanted to take that into a physical model, we needed to add a pair of linkages because we only had a restriction between a link and the wings. So here we add a pair of links to deliver that type of motion if we wanted to build a physical model. And we also put here the graphs of the inputs and outputs. As an input in the slider crank, we have the oscillating motor, and in the crank rocker, we put a rotary motor with a constant velocity. And in both cases, we got an oscillating motion as an output that resembles the results we got in tracker. And as a conclusion, we think that this task of delivering a mechanism by biomimetics allows us to have the opportunity to work with the synthesis of mechanism, where we needed to understand first the movement we wanted to replicate, and then try to develop a set of mechanisms that deliver that movement. And that will be it. Thank you so much.